SFD and BMD for cantilever beam with UDL all over the length. Okay. So this is a cantilever beam which is having UDL all over the length, and this is the fixed support, so that's why there will be a one vertical reaction like this. One, there can be a horizontal reaction if there is an inclined load, and there will be moment resistance. Okay, so for analysis of this beam we will use a very basic equation of a static equilibrium. Okay, so to calculate the support reaction, the very first step for the analysis of a beam is to have to calculate the support reactions. So there are basically three equations. It is summation of fx is equal to 0, summation of fy is equal to 0, and summation of moment about z is equal to 0. So these are the three basic equations that we are going to use. Now summation of fy in is 0. Summation of fy is nothing but the sum of all the vertical forces. So the force which is in upward direction along y-axis will be considered as positive, and the forces which are in downward direction along y-axis, they will be considered as negative. So this is reaction RA. Okay, so this is in upward direction, so that's why it will be positive. Okay, and this UDL, that is W per unit length, it means that for when it covers a unit length, the load on that length will be W. So this is the total length is L, so that's why W multiplied by L will give us the whatever be the total load on this beam, so that is WL, and it is acting in a downward direction, so that's why it will be negative, so it is minus WL, that will be equal to 0. So RA is nothing but WL. So for this beam the reaction is only nothing but in the form of force is nothing but a reaction at A, and it is equal to WL. So this total load is being resisted by this support, fixed support, though that's why it is a WL. So reaction at A is WL. Okay, second is to calculation for shear force diagram. For shear force diagram, that is nothing but SFD. Okay, so whenever we are going to calculate shear force diagram, we use sign convention. Suppose this is the section, and if at the left side the force is in upward direction, or when the force on the right side of the section is in downward direction, then it will be considered as positive. Or another sign convention is that suppose this is the section, and if the forces on the left side of the section are in downward direction, or when the supports on the right side of the section are in upward direction, then it will be considered as a negative. So this is nothing but the sign convention that we are going to use for the calculation of SFD. So this is point A. Now I am calculating shear force at A left. Okay, so when I say shear force at A left, then I have to take a section on the left side of a point A. So this is point A, and I am taking section at this left side of this point, and I am going to consider the forces which are in left direction. So if you see in the left direction there is no any force, so that's why the shear force at A left will be 0. Then shear force at A right. When I say shear force at A right, I consider a section to the right side of a point A. So this is the point A, and I am considering this section at right side of A, and I am looking back in a leftward direction. So when I look in a leftward direction, I found that there is only one reaction, that is nothing but WL, and it is in upward direction. So with the sign convention, so suppose this is the section and towards the left, when it is in upward direction, then it will be considered as positive. So that's why it will be nothing but RA, and that is nothing but a WL, which is in upward direction. So shear force at A right is WL. Now there is another point, that is nothing but the B, that is shear force at B left. Okay, so shear force at B left, when we consider, then I take a section at the left side of this B and I look in a left direction, then I will find that there is only WL in upward direction, okay, and the load which is acting in a downward direction. So when it is we are looking to the left, and if it is in upward direction it is positive, so that's why I take it's positive like WL, or you can directly take from this shear force at A right. You have already calculated that is WL, you have to place it here. Then when I see in the left direction, there is a UDL which is distributed all over the length, and it is acting in downward direction. This total load is nothing but a WL, as I have already told you. It is in downward direction. So if I take a section and towards the left, if the force is in a downward direction, then I have to take it as a negative. So negative, the load is WL, so it will be WL minus WL, that is nothing but 0. Then shear force at B right. Why do we take the like this B left or B right? Because if at a point B, if there is any load, then we have to consider. But when I take at B right, there is a no any other load, or it is not making any difference. So if you again calculate, then it will be also 0, like this. So for drawing this shear force diagram, so this is the beam, or you can say this is the reference line. Shear force at A left is 0, so this is the point of 0. So shear force at A left is 0, and shear force at A right is WL. So suppose this is the point having WL like this. Shear force at B left is 0, and shear force at B right is also 0. So this is UDL, that is uniformly distributed load. Okay, so while drawing the SFD, as this is uniformly distributed load, constant load, there will be the incline variation. So that's why I have to join this point like this. So this is nothing but shear force diagram for a cantilever beam which is subjected to uniformly distributed load. Next is step is to calculation for bending moment diagram. Calculation for BMD. So bending moment at A. Okay, first of all we should know what are the sign convention. So for that, suppose this is the section and moments are like this. I have already explained this. This will is positive and this sign convention is considered as negative. So I am taking bending moment at A and I am looking in the right direction. Okay, so the reaction at A, that is WL, it is passing through point A. So there is a no perpendicular distance between A and this reaction RA. So definitely that's going to 0. So we need not to consider this. But there is a load, uniformly distributed load acting on a beam which is acting in a downward direction. So total load is W multiplied by L, that is nothing but WL. Okay, so it will rotate at point A like this in a clockwise direction, and it is toward the right section or right side of A. So when right side of A it is in a clockwise direction, this will be considered as negative. So that's why there will be the negative sign, and we are talking moment. So This UDL will act at the center of this beam. Okay, so that will be nothing but L by 2. So multiplied by L by 2, that will be WL square by 2. Okay, and it will be negative. Okay, bending moment at A is WL square by 2, and it is negative. So this is the beam, and WL square by 2 is the bending moment, and that is negative. So this is the point WL square by 2. Okay, and this variation will be parabolic variation like this. Okay, so this is the BMD for cantilever beam, which is subject to all over the length. So for the constant load, the when we draw the shear force diagram for uniformly distributed load, there will be the inclined line. Okay, and for bending moment diagram, it will be a 2-degree parabola. Okay, so this is the how we have to draw shear force diagram and bending moment diagram for cantilever beam with UDL all over the length.